In this lesson, we're going to be talking about RAID, and not the chemical that kills bugs. We are going to be talking about the redundant array of inexpensive disks. The idea behind RAID was you would have a lot of disks that didn't cost a lot of money, and if you kind of ganged them all together, you might have one really big disk, or you could have one more reliable disk than you had before, and you wouldn't have spent a lot of money on it. So the idea was that disk drives were becoming more inexpensive, and you could make use of some inexpensive disks in order to get a lot of fault tolerance and better performance than you would with having spent the money on a more expensive hard drive. So right now I've got a Windows system here, and I've actually got a couple of small hard drives we're going to do something with. Now, what I want to do, first of all, so if I go into disk management here, I've got a couple of hard drives, and the first thing I need to do is initialize the disks. So I'm going to go through and get those initialized. It's going to put some partition tables on and get them to the point where if I scroll down, I can create a new mirrored volume, for example. Now, mirroring is one of the modes of RAID. So there are a number of RAID modes. RAID 0 is like if I've got two drives and I'm really creating one drive out of them, and it's called striping. So with two drives, I can stripe data across both of the drives. It gives me one larger drive than I had before. RAID 1, which is really what I'm doing here, is a mirrored drive. So I could add this second drive here. And what I'm going to end up with is one drive that's the same size as just one of them. But what happens is anytime I do a write, it's going to write the data to both drives. So now I've got a backup in case one drive fails. I've got a backup on the other drive, and what Windows will do in that case is it will just read data off the mirrored volume. So I could have done mirrored, I could have done striped, I could have done striped with parity, which is RAID 4, and that's where one of the drives, and at that point you have to have multiple drives. At that point, I could do parity, meaning there's like a checksum that gets stored on additional drive, and RAID 5 is striped with the parity across all of the drives. Now, you can kind of mix and match some of these, like you could do RAID 1 plus RAID 0, so that's mirrored plus striped, but that gets kind of complicated. And I've got the ability to do RAID here in software with Microsoft Windows here. Some computers will actually have a RAID controller built onto the motherboard. And the idea with that is it's a little bit faster. It used to be a long time ago you couldn't do RAID in software because it wasn't available to do. So you had to do the hardware RAID. Nowadays, you can do RAID inside of Windows, you can do RAID inside of Linux, and I'm actually going to show you the drive right now that we just created and show you it's actually empty. There's nothing on it. That's a mirrored drive in Windows. Now let me show you how to do the same thing in Linux. And the first thing that I want to do is just create a new partition table. And I want to create that on both of the drives. Now that I've got the partition tables created, now I can actually create the RAID array here. And I'm going to do md80m, which is going to create my RAID array. It's the software package. It's actually going to do the configuration for me. So I do --create --verbose, and I'm going to say /dev/md0 level equals 1. So I'm actually going to do a mirror -raid-devices equals 2, and then /dev/sdb and /dev/sdc. So now I've actually got this RAID array here, and I can actually check it with cat/proc/mdstat. And so I've got one active array using SDC and SDB, which are my two additional hard drives in this particular system, and it shows an active RAID 1 array. So again, we've got RAID, which I can do with either hardware or software. As I've shown you here, software is actually pretty easy to do in Linux and in Windows. And the reason for actually going over this is because as a forensic investigator, if you've got a hard drive, if it's part of a RAID array, you may actually need the additional hard drives in order to retrieve the data. If you've just got one part of a mirror set, you're probably going to be okay. If you've got part of a parity set, then you actually need the additional hard drives to recover the data from, because you could have data stored across any of the drives in the RAID array. So RAID is really useful for getting fault-tolerant drive setups. It's also good for getting one large drive from multiple smaller drives, but make sure you have all of the drives out of the RAID array before you start trying to access it. Otherwise, you run the risk of destroying the data and not being able to recreate that RAID array once you do get all of the drives.